Hello, Scott Hebner here. Thank you for joining episode number 6 of the Next Frontiers of AI podcast, where we will continue our discussions with industry pioneers that are shaping the future of AI. Since we launched this podcast just over, a month ago or so, we've heard from a very diverse set of innovators from G2 and Scamby and Fitch Ratings and Geminos. Today, we add to the mix a trailblazing data scientist from the BMW Group. We will discuss how new AI technologies are improving how supply chains are dynamically managed. And I will tread very carefully, I think, because he's an actual Ph.D. I only play one on TV. So, okay, before we get into our discussion, just a little bit of context. Most businesses have become accustomed to using AI for making predictions and analyzing information and automating tasks and creating new content. But forward-thinking business leaders want to do a lot more than just that. They want AI to help them understand how their business actually operates, not how they think it operates. They want AI to understand how changing conditions affect outcomes. They want AI to help identify and remediate root causes of problems. They envision a world where they can play out countless what-if scenarios and understand the consequences of their actions. In essence, they want trustworthy and transparent AI systems that not only understand what to do, but how to do it and why certain action paths are better than others. What many would call AI decision intelligence. And don't just take my word for it. The MIT Sloan Management Review just published a new report that explores how the advent of causal AI is allowing managers to answer what-if questions and explore different options to improve their decision-making capabilities. In my view, this is a big deal. This journal is one of the most credible and influential publications within the business world, alongside the Harvard Business Review and the McKinsey Quarterly. Causal AI has now evolved beyond the technology elites into the managerial class. And when managers read this, they're going to be like, well, duh, I want that. I can only imagine all the messages and phone calls flowing to the CTO and the CIO and the chief AI officers. How do we do this? Let's do this. I think we're witnessing the acceleration of the next phase of AI in business in terms of the journey that people are on. AI systems that can actually reason. AI reasoning will build upon the foundation of predictive models and generative AI and LLMs. We are seeing very good progress being made in the marketplace, and some are taking the first steps, such as with chain of thought. Chain of thought being offered by, OpenAI, DeepSeek, IBM Granite just announced it, just to name a few. But chain of thought is just the first step. It's the next steps that will have the biggest impact. While on past podcasts, we have heard about the impact that these advancements are making in the industries of ad tech, industrial, financial services. Today, we'll hear about how causal reasoning is helping create more resilient supply chains within the manufacturing process. To discuss this with a lot more detail, I'm thrilled to be joined by a heavyweight PhD, Ishansh Gupta, who is the lead data scientist for quality management at the BMW Group. Thanks so much for joining us, Ishansh.
Thanks a lot, Scott, for welcoming, and happy to be here and happy to share my journey.
And hopefully I'm not butchering your name. I have terrible pronunciation of name problems, but I really appreciate you being here. And you're in Munich right now, right?
That's correct. Yeah, I'm right now in Munich at 6 p.m. just after work time. So early evening right now.
Yep, on a Friday night, so everyone knows.
Yes.
That's how committed he is. So look, I always like to start with a little story about our guest's personal journey on how did you end up where you are now? What's your story? Just a little bit of background for our audience.
Sure. I come from an interesting background, originally Indian, an expat living here in Germany. It's been around 5 years, 5 wonderful years. Initially, I did my bachelor's in computer science, then ended up doing my master's in Germany, north of Germany, in data engineering, and then got a brilliant chance to do my PhD alongside BMW in Causal AI. And yeah, now just living here, having a really good time, and also regarding technology, learning new things every day. Regarding my background, also, I come from an interesting background where my parents, both of them, they are doctors, and me being the fake PhD, um, um, yeah, the fake doctor.
Well, I'm really glad we hooked up. It's the power of LinkedIn, right? And we've had some really great conversations. But um, what causal AI is something that I think one of our past guests showed a chart, what you can do on Google in terms of search volumes, and it's only been over the last 3 years or so that it's like a hockey stick now. It's starting to be searched on, and which means people are getting interest in it. But what motivated you to pursue? I think what would have been a niche field at the time that you actually got it. I mean, like what's the difference between getting a PhD in traditional AI and why did you go with the causal route?
Yeah, I mean, as you mentioned, that there has been a spike lately, especially you mentioned the past 3 to 4 years, which is exactly the time if you see that there has been a lot of disruptions. I mean, especially talking about automotive industry. I mean, you talk about the Eastern European War, or you talk about the Corona pandemic. You talk about the semiconductor issue. What it did is that there was a motivation to and a desire to go beyond the black box predictions of traditional AI, because whatever we were predicting, since the future was so uncertain, the predictions were not accurate at all. So I mean, traditional AI, it's really great at spotting patterns, but it really struggles with answering this what if questions that definitely are super important for decision making. Whereas causal AI, this new term, it's designed to find the what if or cause effect relationships. So, I mean, what how I see it is that it's not just mere predictions, predictive outcomes, but it's more than that. You can simulate and explore different interventions, and essentially, it gives you that what if machinery. I also see it as like Sherlock Holmes of AI, because it will not just tell that, okay, my part will go down or it will go bad, but it will also tell me the reason why. And yeah, I mean, that was the motivation, and that's how I also got it in the field.
Yeah, I love. I don't know if you had a chance to read it yet. I mean, I had to pay $6.95 for it, but I guess it was worth it. But the MIT Sloan report that I talked about earlier, I mean, they make a good case that today's correlative designs, today's AI essentially, it's flawed when it comes to making decisions, and managers are going to have a hard time trusting it. So I think you got yourself into the right field for sure. Certainly from my perspective, but I think it's going to turn out because everyone's really going to want this stuff. It's not brain surgery. I want to be able to intervene with the models. I want to explore these different options I can do. I want it to explain to me how and why. I mean, I just think it's going to get there. And but in past interviews that I've done, there's been a lot of focus on trust, right? And there's good evidence from McKinsey and others, technology research and others, that AI deployments are actually slowing down a little bit in the enterprise because of the issue of trust. And managers and executives and just everyday people need to be able to trust these models more, which I think comes down to explainability. And I think a lot of this causal stuff is going to help address that. But how do you see causal AI helping to gain more trust from management, right? And getting them to trust it to actually help them make decisions? Because you did that, right? You've had some experience at
Yes,
BMW. And
that's correct. I mean, you mentioned the word trust. I think that's super important. I remember giving a conference 2 years ago in Manhattan and talking about this thing, that the future of supply chain, I think it's not more technology or better technology, but better trust. And Causal AI is definitely one tool that helps in reducing that trust deficit. And I think you mentioned the MIT report. I did get a chance to read it, and you also talked about the power of LinkedIn. So I think I follow these researchers. I think they happen to be also from Germany. So I did get a chance to read the report, and I think the report is spot on. It's I think I shared the same experiences. It highlights how Causal AI empowers the management, these managers, to simulate various different scenarios and then evaluate the potential outcomes before making the decisions. So I think this proactive approach that they mention is more of a requirement than a luxury, in my opinion, and it just transforms you from being reactive to be more proactive. And I think when managers, they really see the potential of answering these what if questions with clarity and precision, I think it's that iPhone moment for them, and they realize that it's just not theoretical, but it's a practical tool for solving really complex business problems.
Yeah, Stuart Frost, the CEO of Geminos, who I had on last week, he made the point that his experience is once you go there, you're never going back.
Yeah.
And yeah, I mean, I thought the report was really well written. I mean, it's obviously targeted at a business and the executive level. And for those of you that like Lindt chocolates, you should know that Causal AI is helping to manufacture those more efficiently.
Yeah.
I thought there's some really good case studies in there. What they didn't get into is technology, really, right? And so for our audience and in the marketplace in general, generative AI, LLMs are all top of mind right now. They're critically important in my view. I mean, I think they provide the gateway into AI, sort of like the browsers provided the gateway into the internet, at the internet age, early internet age. But how do you see the intersection of causal AI and generative AI in terms of what's coming next in the future?
So, I mean, both of these buzzword, causal AI, Gen AI, I think there is a lot of confusion when people talk about that, because I see that a lot of people, when they talk about it, they see it as two different terms. And I mean, it is, but there are definitely things that are very complementary. Both are on a way that makes you a bit more proactive than just reactive. And it's a field that I actively research on, and trying to combine both the technologies and leverage both of them to be a bit more proactive. How personally I see it is that, and that's how I also utilized in my research, which I did with BMW, is that it can be a tool which can be used to optimize and make causal discovery process a bit faster. In my research, I've interviewed multiple different experts in order to gain their tribal knowledge and input in my causal models. But what's one thing is that it takes a lot of time. And I think that's where Microsoft has also a really brilliant paper regarding that, where they have this, that the next causality is the next frontier. And they also talk about that how we can leverage causal AI in order to expedite the entire process of causal discovery. And that was my motivation, and I tried it myself, had the similar experiences, and I just love this combination of both of them. And also for the simulation part, I think once we unravel these cause and effect relationships, leveraging causal AI for the simulation part also, I think it's brilliant. And I mean, imagine that when I build a tool using causal AI or even traditional machine learning, in the end, if I have to give it to, let's say, people on the line on different plants at BMW, I imagine that they'll have their phone in their hand and ask questions like how they ask ChatGPT that, okay, tell me that in the next 5 minutes, what are my stations gonna go down? What will be the reasons why? And then they add this causality layer also to that to give me a proper answer. So it's brilliant, and I definitely see that if it's already not a present, it's definitely will be a big part of the future.
Yeah, I loved a graphic that Stu Frost, again from Geminos, had in the last podcast. It was a picture of two sides of the brain. So the left side was fast, and the right side was slow. So the fast side was LLMs, right, in generative AI, and it's your core knowledge base, and it helps you generate and automate things. And on the right side was the slow part, which is what they call a causal knowledge graph, which captures human knowledge, know-how, some intuition, but also through causal discovery and ongoing, operation, it learns the real cause and effect operations, and they have this causal RAG. And then that just feeds back into the LLM, and the LLM understands the real world, and it just kind of is a circular learning loop, right? And I think that's what you're referring here, that these two things come together to be complementary. And really, you can think of causal AI, I mean AI reasoning in general, including semantic reasoning. It's building on a generative AI and LLM base, right?
Yeah, that's exactly my understanding. I mean, I also have a research paper on that. by combining both the different technologies. But I mean, like I mentioned, and how I started initially, that I see it as a very complementary terms, and people are always like, I think, misunderstood. They always misunderstand these two different terms, and they talk it in two different perspectives. But I feel that they are very complementary things, and we should leverage both of them together in order to be a bit more proactive.
Yeah, I think we got to keep driving it. It's just a progression, right? It's no miracles required. As I said last time, it's just progress. And this is a step in the journey that builds on generative. I just get the sense that, just be a business person, right? You're running a business, and this stuff's moving so fast just over the last 2 years. And there's generative AI, now there's agents, and there's agentic AI, and now, RAG, and people are having a hard time keeping up with terms. And then they hear causal AI, and it's just like, I don't know if I can deal with another one yet. But I think everyone has to just, step back and realize that the innovation cycles are moving so quickly here, and it's just a progressive set of capabilities. And I think that's what you have been writing about, right? Like, I know you've worked extensively with tribal knowledge, sort of in the causal AI models, right? So, what insights do you have in the role and challenges in building, reliable models, right? Because it's one thing to be able to do decision intelligence, what ifs, counterfactual reasoning, understand the causal drivers of how your business actually operates, blah, blah, blah. But like we said earlier on, you need reliable models. Otherwise, if no one trusts them, then they're of no value.
I think super important and very correct. I mean, tribal knowledge, if you really, really think, I think it's a gold mine, but also a really, really big challenge. So on one hand, yes, you'll be incorporating all these brilliant knowledge of the experts, these deep-seated expertise, which definitely can significantly enhance the model. Um, but also, I mean, if it's not done correctly, it will be biasing the model. And I think that's one field that I've also had experience researching on. So if I might, I'll recommend a technique. It's called multi-criteria decision making, which through which you can try to quantify this tribal knowledge. And what it does is that, I mean, the key is to combine this expert intuition with robust statistical method, and so that we can ensure that the causal models that we'll be building in the end, they capture both the nuance of human experiences, but also the rigor of empirical data. So there's this method to this madness. You sit down with the experts, try to interview them in a very statistical way, but also you make sure that you are reducing the bias. So you have to make sure that you are doing it with multiple experts. And this integration, although it's very challenging, but it results in models that are, I feel that are not just accurate, but they are also aligned with the real world decisionship making. And my experience, like, people love telling their knowledge, and once they see that in the models, uh, they're willing to play with it. So my experience also was that initially, when I inputted these tribal knowledge into the models, uh, the experts really, really loved it because they saw it as an extension of their own brain, and they were willing to play with it. So initially, even if it was not the best, just their willingness to play with it and make it better made it really, really good in the end, I think. And that's again talking about the reducing the trust deficit. Since they believed in it, they were able to make it way more, and they saw it as an extension of their own brain.
Yeah, at the end of the podcast, we're going to give your LinkedIn ID so people can contact you if you want to get access to the papers that you've published and other ones that you think would be helpful. So let's transition a little bit here to supply chain, supply chain resiliency. Which is what you've been really focusing on, right? Historically, and what you're doing now. So let's start with the limitations of traditional, correlational AI when it comes to supply chains.
I mean, supply chain is something where I think the need of causal AI is even more, because, like I mentioned, some of the problems earlier about the Eastern European war, or the external factors like the war or the pandemic, they affect supply chain like more than ever. And it's a very, very, very different world, and you cannot predict things very, very clearly. And imagine that the classic example where we talk about the talk regarding correlation versus causation, and it both are not the similar terms. I mean, that's where the need of understanding that if something is actually causation or something is actually correlated becomes even more important, because their entire strategy of supply chain can be based on that, and it could result in really, really big losses. So the need of causal AI in supply chain is definitely more than ever, and it's definitely heightened in supply chain. So the need to first understand that how these external world can affect my supply chain, my suppliers. First, you have to understand that, and then be a bit more prepared, because understanding is one thing. How do you go to the next step? Because the managers, they just don't want that okay, something's going to happen and why something's going to happen. They also want to know what's the next step. So they want the simulation, or they want what's the next thing you should do. And I think that's again where causal AI plays a really, really important role, where I can simulate different scenarios. Also, I can simulate some of the historical scenarios, that what if I would have taken a certain action, what would have been result in that scenarios. And I think that again helps with the trust factor, and it makes you a bit more better prepared.
Yeah, I've always thought of it as, the correlative, today's stuff is only as good at predicting the future as if you assume that the conditions surrounding it won't change in the future, right? The dynamic nature of adapting, and some of the things that, because causality is all about telling you how statistical probabilities change when the world around you changes, right? As Judea Pearl kind of points out. So I think it's fascinating. And one of the things you've been focused on is the notion of resiliency in the supply chain, right? So, how does that even work?
Yeah, I mean, so by identifying all these key drivers of the performance, I mean, what companies can do is that they can build robust strategies that can account for all these different disruptions. So whether it could be economical shifts or natural disasters or unexpected market changes, the ability to answer these what if scenarios for proactive planning and risk mitigation, it ensures that the supply chains are not just efficient under normal conditions, but are also agile and resilient when they face with these unforced challenges. Because I think the art of building a resilient supply chain is also believing that it will not always be constant. Things will keep happening. Things like Corona, things like different wars will keep happening, and you have to be a bit more prepared for that. And that's where you have to keep doing these simulations, be a bit more prepared, and come up with better strategies.
Interesting. So the notion of a resilient supply chain is that it adapts with the conditions and allow you to make better decisions that take those kind of things into account using AI, obviously, right? It actually sounds pretty familiar or similar to the conversation I had with Jaida Pudatanda from Fitch Ratings, but it was in the context of financial services. And, when you're dealing with finances and trades and bonds, you got to keep, interest rates change, regulations change, currency stuff changes, and how do you keep track of all that stuff and have the models evolve and let you do those what ifs? And you're just applying a similar kind of dynamic nature to a supply chain, right? And by extension into the manufacturing process. That's pretty cool. Well, let's bring up the causal knowledge graph for a supply chain that you had. There it is. Can you explain that a little bit?
Sure. I mean, so that's a really, really beautiful one of the results that I got by interviewing different experts in supply chain. And I mean, took a lot of energy, took a lot of time, and shout out to one of my student, Taha, who helped in building this thing. So what it basically, this knowledge graph, or the tribal knowledge graph that I call it, represents that the interdependencies with the supply chain, which highlights all these causal relationships between different components. So it's a DAG, and each node represents a critical variable from supplier reliability to what are the external factors, and how it affects the internal KPIs of my suppliers, like wrong deliveries or missing parts or backlogs. Now, what's powerful regarding this is that it not only shows the correlations, but it implies causality, and it provides a roadmap for where interventions might have the most significant impact. So it can be a tool that transforms all these complex systems of supply chains into more manageable and understandable structure. And then you input all this knowledge into your causal AI models. You can play around with different variables, and then you can answer the question of your managers when they say that, okay, what if now we have a roadblock, or my some of the suppliers are on strike, what how it will affect the backlogs of my supplier. So we are not just telling them that, okay, your backlogs will be affected and maybe they will be 20% more, but you can tell the exact reason and also quantify it. So you can tell them that how much effect it can have. And yeah, I think it's something that should be mandatory for most of the supply chain experts to do it, and then eventually bring it into their models.
Yeah, so that's one of the big differences from a traditional knowledge graph is if one of those entities changed the condition, like like you said, like people went on strike in a certain state or something like that, the causal will then reflect the changes across the whole chain of effects in all those other entities that are in the model, right? And
Yes, exactly.
yeah,
I mean, also, like, you see that one of the examples in the table that I really, really like is that, let's say, when there's a harvest season, it comes, and then it what it results in that, or it causes that people take leaves, that could affect in us hiring temporary workers, and that could lead to human error. That in turn affects the backlog of my supplier. So we are not just telling that how harvest season affected the backlogs of my supplier. We could give a very transparent answer to the managers, and tell that, okay, this led to this led to this, and that's why the backlogs are being reduced. So we can find a way that how we can try to manage the situation in future. So that's
right,
again like one of the powerful thing of this tribal knowledge graphs.
right. And as I kind of said before, I just play a PhD on these podcasts, but I'm not really one, obviously. But let me just try to piece this all together, and you can tell me if I'm thinking about this right. So you get together experts, right, in the organization, and and this can be anybody, not necessarily you, right? But you kind of create your knowledge graph, or and then you start to map the causal effects, how changes in one area change in another, and you're using some human expertise, and you basically come up with a causal knowledge graph to get started. And then as over a process of time, you're doing causal discovery on real data and real situations that then further build out and adapt and make more accurate the causal knowledge graph. And so it just gets more and more reflective of real world conditions. And then that feeds back into the generative AI and the LLMs to give you the general knowledge and to be able to do, the interaction with humans and create stuff and do. Is that sort of how it all comes together?
Yes and no. So that's one way. I mean, you sit down with the experts, try to gain their tribal knowledge, and input into the different causal AI models, which will help in simulations, because you have already identified the cause and effect. And then, of course, you can leverage LLM in order to explain this graph also, but also to get different analysis. That's one way. What I also tried out is, why not just use LLM in order to generate a similar graph like that, and then get it validated by the experts. So of course, different experts will have their own unique experiences, which potentially the LLMs will not have it already. But what I've learned from my experience also with talking with experts is that people love to criticize. So initially when I interviewed them, they were like, okay, yeah, maybe we don't know a lot, we'll see how the conversation goes. And by the end of the interview, after spending 2 3 hours, they'll be like, damn, like, this is a very amazing craft that we have got in the end. So why not directly use LLMs, generate a DAG, a very beautiful DAG, by giving three to four different prompts and making it a bit more complex, and then get it validated by expert. They criticize it, they make it a bit more better, they add their unique experiences. And one, it will be faster, and second, again, like I said, that it will be even more engaging. And after that, what result you will get is something that is very close to the ground truth. And when you do the predictions in that, it will definitely reflect the ground truth.
And the DAG is a direct acyclic graph that is part of the causal math that Judea Pearl in his book of the Book of Why is right.
Yes,
Okay,
that's
it's
definitely correct.
the construct. All right. Well, you mentioned you mentioned working with the experts, and Alex, if you can bring up the chart on the output of all these experts. And Josh, why don't you just kind of describe what you found here as you did some of this evaluation with your expert friends?
Sure. I mean, so one of the things that I wanted to research was not just interviewing these experts in order to build this tribal knowledge graph and then put it into different models. What I also wanted to do is compare the traditional machine learning approaches with the conventional descriptive approaches and then the causal AI approaches, and then see that on different business metrics like business impact or stress test, which is a very important KPI in supply chain, or explainability, which is again important for managers. How does these three different approaches pan out? And I just didn't wanted to have a feeling that I personally knew that okay, causal AI will end up doing pretty good, because I also come from a business background, and I thought that if I'll put my business hat on, I think that should be the expected result. But I also wanted to quantify that by how much better it will be, and will the managers perceive it the same way. So we interviewed different experts with different demographics from different countries and different plants, um, and with different seniority experiences. And the results we got were really, really satisfactory and super interesting, in my opinion, especially if you talk about few results like explanation capability. So, I mean, with all these buzzwords, AI, Gen AI, imagine that if you go by this reading, and I invest €1 million as a manager in a traditional machine learning approach, it's very close to a current traditional descriptive approach. So that could mean that the €1 million that I spent, maybe my people on the line or the actual experts are not even willing to trust it, and they don't see the value. Whereas if you see that there is really big difference with causal AI, because we were directly able to show and explain our reasons. The experts were not being lost in post hoc explainability methods like Lime or SHAP or the root mean squares and all these different buzzwords. I could just directly show them the causal discovery graph, make it more interactive since it's a DAG, have different nodes with green and red edges. They could play around with it, and then in the end they could simulate and come to their own understanding and the answer. So these results were really, really satisfactory, something that I expected. But yeah, I mean, was another thing to get it validated and get it validated quantifiably.
This is really interesting stuff. Very much consistent with what I've been hearing from those that have been, either experimenting, and obviously some have this stuff deployed in like Scanby and others. Very, very cool. It's also, by the way, consistent with what was reported in the MIT Sloan study, right? The outcomes are, they're starting to become proven. That's part of the reason why I just think over the next 2 years will drive more innovation than what we just saw over the last 2 years, right? And I would actually say more meaningful innovation in the next 2 years than what we just saw over the last 2 years with generative AI. Because I think generative AI creates that foundation, but this causal AI stuff is going to make a big impact. I mean, particularly when you think about AI agents and agentic systems that are supposed to be decision-making entities, and they plan, and how do you do that without the capabilities you're talking about, right? Doesn't it just need to become part of the AI fabric inevitably at some point? You agree?
Yeah, I'm totally with it. I mean, something interesting that I also want to share from these metrics is that a lot of people, when they see these different results, I mean, first of the thing is that they are definitely amazed, but the other thing that they bring out is that isn't it comparing apples to oranges? That isn't it suppose that causal AI should be better? And my point is exactly that we talk about three different levels about descriptive analytics, then predictive analytics, and then prescriptive analytics. I see causal AI as kind of a mixture of everything. And my suggestion would be, why not directly go into the causal layer and skip all these traditional approach of going into descriptive and predictive AI. Why not just directly go into causal AI, which is more explainable? It's very visual. People love visual things. It's more impactful, and again, it's way more than mere predictions. It's not just an interesting number in the end. It's way more, and you get a proper business recommendation, and that's the need of the hour, and that's exactly what the managers and the management wants.
Yeah, it's an evolution from tasks to goals and from predictions to judgments, right? And then judgments collectively are what allow you to make decisions and problem solve. And in human brain, it's a natural progression. Ishansh, this has been a great conversation, and actually very inspiring. But I do want to, before we end here, you have been doing a lot to give back to the community, which I think is super impressive. And also inspiring. And I think you're hoping to create, shape the next generation of data scientists. You recently, back in the fall, held a very successful Causal AI hackathon with the support of BMW. I think that's how we initially connected in the first place. And so, can you just spend a little bit of time before we wrap up here on what was the goal behind it, and what were some of the takeaways, and are there going to be more? And it looked pretty awesome.
Definitely more. I mean, so I'll tell you the thought process regarding this hackathon. I mean, personally, I feel that causal AI is something that has definitely transformed me as a data scientist. Also, I think it definitely has made me better. And my intention was to one, spread the word. I mean, I see a lot of people just not knowing about this technology, and I think that's where also you are doing an amazing job with podcasts like this and just spreading the word. And I mean, with all this technology, I think one thing that is definitely will always be superior is the people. And I put a lot of emphasis in hiring the best people. I have a lot of experience in hiring in BMW and also with some other companies. And I have a very unique way of hiring where I'll give them different case studies, make it a bit tough, make it a bit more interesting. And I thought that instead of doing that case study method, why not replace it with a hackathon and do it a causal machine learning hackathon? So it does two or three good things. One is that I'll get the best talent. Second is spreading the word of causal AI, that people from the university will know that there's this new technology. They'll try out different things. And then also, like, I personally always want to be in touch with the academics. I know the potential. I know that the students are really brilliant. They'll always have different and new ideas. And yeah, just want to foster this collaboration and innovation by bringing together these different diverse talents, data scientists, domain experts, and business leaders to tackle some of the real world problems. That's the case study that we gave to them, which was very close to some of the one of the biggest problems that we were facing. And the goal is also to break down different silos and show how causal reasoning can unlock new perspectives and solving complex problems. So I mean, few takeaways that I had was, one, collaboration is the key. I mean, imagine like different students from different backgrounds, cross disciplinary teams. They combine technical insights with practical experiences and create something very unique and something interesting. Then second, practical impact. I mean, participants were definitely left with clearer understanding of this new technology, causal AI, that could be applied to numerous use cases and could help in helping different strategic decisions. But also, I feel that it gives a edge to students who are also competing against other students for different jobs. Because I think, like, imagine companies like Netflix. One of my student, she got a job at Netflix because they use causal AI a lot, and she could do practically a use case study, and she did pretty well in that. And via hackathon is she got to know about causal AI. And the third point was is the future potential. I mean, it sparked different ideas. Also, combining causal AI and agentic AI with Gen AI is also some of the ideas that students had, and it just influences new ideas, new projects, and collaborations with the industry. So I mean, super positive experience. And my personal goal was definitely achieved of just spreading the word. It gave me a lot of happiness when students were talking about causal AI, when they were facing different challenges when they were applying causal discovery, because we gave them a high dimensional data and they were facing some of the cliche problems that, okay, my causal discovery graph, I'm not able to build it. There are just 1,000 edges, 1,000 variables. How do I do that? And then they were using things like ChatGPT in order to solve it. So it was very satisfying. And yeah, like a really successful event. It was sold out in just a couple of days. And definitely in future we'll try to have more things like that.
Well, it's awesome. Congratulations. It's been a real pleasure getting to know you and learning about the impact you're making. And we'll definitely stay in touch here and keep us up to date on where this is all heading. And definitely let me know when you're running the next hackathon. I'll help do whatever I can do to get the word out, because I think those things are great. Okay, well, it's time to go. I really appreciate you taking the time here. And, thanks to Alex Meyerson for producing the show today. And thank you all in the audience out there for watching. As always, it's really appreciated that you're tuning in and being a part of all these great conversations and hearing from our guests. Do please contact us if we can help you out in any way. And stay tuned for more research and analysis from our team as we dive deeper into what's shaping the future of AI in business. Visit us at thecuberesearch.com and siliconangle.com to stay connected and to access all of our research and podcasts from both me and my peer analysts. So, hey, we are the leader in tech news and analysis. Bye for now. See you next time.